Okay, so hello. I'm excited to see you all. I have to let you know there are no hot dish recipes in this talk. So I did appreciate that. Good Minnesota shout out in there. I do have some local pictures though. All right, so we're gonna talk about cloud and containers and Kubernetes and some of the somewhat annoying human factors when adopting all of this stuff. My name is Bridget Kromhout. I live here, actually. So it's super exciting to sleep in my own bed and wake up and pet my own attack kitten before coming to a conference. That is, conference hotels have a surprisingly low incidence of cats that you can enjoy in your room. So, I work at Microsoft. I have a t-shirt with glitter and sparkles. I did not make it. It is an official licensed Microsoft product. So I don't think you can get it unless you go to the company store. So, and I do the podcast with Arrested DevOps. If my voice sounds familiar, but I don't look familiar, that might be why. And I am the chief cook and bottle washer of the DevOps Days organization. So more on that later. We do have DevOps Days Minneapolis coming up here, July 12th and 13th. But I actually, from Minnesota, run the global organization. We were in 55. I think we're going to be in 55 cities on 6 continents in 2018. So if you would like to run one in Antarctica, perhaps at McMurdo Station, I'm sure they have DevOps needs. Let me know. Okay, so let's talk about cloud. This is a tweet from Simon Wardley where he was polling people, some months ago about Meltdown and Spectre. And if you can't read it there, he's saying, our private cloud is going to be patched like some amount of weeks after AWS or months after AWS, or like the more likely, the more reasonable answer for a lot of us who are, when are we going to patch this? Well, when we get the person who needs to do it back from the boundary waters, or probably never. We won't have patched that particular terrible thing by the time the next terrible thing comes along. And this is more typical and more frequent than I like to admit, but we know it's true, right? And I think that this is like that space where, I don't know about you, but I am really sick of the word disruption because it feels entirely predictable. It feels like we should not be surprised if we're playing Settlers of Catan and the Pirates raid. Like, really? You didn't build any knights? You didn't feed your knights? You should expect this. This keeps happening. And the fact that like, oh, spoiler alert, we need to improve and change our IT systems in our organizations. I feel like in 2018, this should not be a surprise to people anymore. And yet, here we all are having those discussions with people where it starts to feel like we're repeating ourselves, because we are. I do think that it would not be a presentation about some sort of dev/ops thing if I didn't mention Conway's Law. But I want to, and you've all heard this a million times, and if you haven't, the short version is there was a paper, and I want to say it was like, I don't know, the late 1950s, early 1960s, and it was called How Committees Invent. And I don't know about you, but I probably would not read something that has that like non-clickbaity of a title. But it did actually have a pretty good bit near the end, many pages into the How Committees Invent, where Mel Conway pointed out that your communication patterns inside your organization are going to map to what your organizational structure looks like. Or rather, what he said is your system that you create is going to copy the design of your organization's communication patterns. And that's it's subtly different than how I first phrased it, right? Because a lot of times you're in an organization and people want to reorg. And they say that they need to reorg because of the new product direction. And you're like, so are we going to reorg every time we do something new? Because that's not going to scale. But sometimes they do, and it's terrible. And I think it's important to remember that it's okay to have an organization structure that you had 6 months ago if the people are willing to talk across the organization. Like, you don't need an entirely different matrix organization to have communication. It might help, but you don't need that. What you do need is the ability and the will to talk across your organization. I want to bring up really quickly, because when we're working with complex systems and we're building really complex systems, one of the things that happens a lot is that you ask someone in the meeting, well, why do we need to build the custom Erlang message bus? Like, why exactly? And sometimes they admit, because I would like to build an Erlang message bus, and you're like, excellent, okay. As long as we've established that's the goal, that's what you're trying to accomplish. Because a lot of times, people want to introduce more than incidental complexity into your systems, and with no particular plan for maintaining it or upgrading it, but they really want to have done it. And then they'll level up and do their next thing. And this is one of those things that it's really hard to say no to, right? Because we're all techies, we're all nerds. I don't know about you, but I got a computer science degree because I didn't want to talk to people. Spoiler alert, it's all people. But Soylent Green and tech are made of people. But it's one of those things we need to watch out for, right? And I think a lot of it is trying to focus inside our organizations on what the actual goal is. Like the goal that drives the success of your enterprise, of your whatever your organization is trying to do, is probably not wrote a custom Erlang message bus. Like that probably does not make you money or help you get to your objectives. There might be results that do, but I think people really tend to focus on the specific technologies instead of, like what could actually get you to your goals. So that brings us to cloud. Like we've been talking about cloud in general, and I would just say, like, when we're making those cloud decisions, having cloud is not a goal in and of itself. I mean, I worked for Microsoft. We would all love you to use Azure. Use some Azure today, et cetera. We have Microsoft people out there, and I have no idea if they have free trial stuff or not, but I assume they have something. Point being, though, you don't go to cloud to go to cloud. You go to cloud if it solves a problem you actually have. Like your lease in your data center is running out, and you're kind of sick of having vSphere and sadness, and you would perhaps like to not. Like that's a reason to look at cloud. But focus on the stuff where it would actually make a difference for you. Like if you're gonna, go to Google and use TensorFlow or whatever, like if you're going to just have much faster turnaround on spinning up VMs that you need, like those are reasons to go to cloud. Just to have cloud is not a reason. Okay, so that's cloud. Containers are an interesting discussion that have been going on for some time, maybe a lot longer than some of us think. I have some history lesson stuff in here in a bit. But looking at like the container landscape, I want to give a personal anecdote, which is I joined a startup in 2014, partially because they started running Docker in production in 2013. It was a little streaming video startup you've never heard of. It was called Drama Fever. And it was like Netflix, but for Korean soap opera. And ran Docker in production in October 2013, when the main thing on Docker's website was like giant letters in Blink that said, under no circumstances should you run this in production. And they were like, YOLO. And they got acquired by Warner Brothers. So I guess sometimes YOLO works out. But not saying I recommend that. I'm saying that that did teach me a lot of stuff about, I was there for a year, and it taught me a lot of stuff about what containers can help you with and what they can't. Like, it solved a lot of our deployment problems. It solved a lot of our reproducibility problems. Having containers in play made it much easier to scale, to auto-scale, to get rid of the works on my machine problem. And get rid of because the containers going out to, the container images going out to production, we're going through a CI/CD pipeline. So we stopped having the problem of the version that works is only on that dev's laptop and it got pushed into production and it's not even in source control and ... profit. Yeah, that is the sort of thing that can and does happen, but it doesn't happen if the only way stuff gets to production is by going through your CI/CD pipeline. Okay, so it did make for like a much more consistent development experience. There was no like, we have a new developer and now it's going to take a while for them to get their local environment to be just right. Like we didn't have that problem. And this is like 2014, we didn't have that problem at all. And we had a very, very consistent deployment process. Does that mean everything was perfect? Wow. Okay, so it can also introduce a whole different style of incidental complexity, right? So, I mean, there's a lot of things around storage drivers, for example, that, kind of just, I still wake up in a cold sweat twitching, thinking about, Docker and storage drivers. So like, there's a lot of entertaining ways that complex systems can fail. And I think it's really common for us to want to pick a technology like containers and cloud. two great tastes that taste great together, like chocolate and peanut butter. But you may get indigestion from them, just like fair warning. And like quick, by the way, container history, I would love to see a show of hands of anyone who used containers pre-Docker, because I know some of you are out there. All right, we got a couple in the room, and like they've been in the kernel for a really long time. I have used, zones and jails, and like it's all a question of how you're implementing the isolation. The LXC stuff that a bunch of folks from Google were contributing to, we're bringing containers to Linux. Like this is great. This is also, containers are not new. They did become a lot more mainstream in the last decade. And again, there were a lot of parallel forks and semi-competing efforts. And it's easy to think like, oh, we have the OCI like image format now, and oh, we have Kubernetes now. But it's useful, I think, to look back and say, even in the not too distant past, these were not settled questions, and it's still a very fast-moving space. And so if you're worried about not being caught up on containers, like, don't worry, no one else is either, including people who do it for a living. You can go look at the GitHub issues on any container-related project, and you will see that. Okay, so Kubernetes also, like, it feels like it's just kind of arrived on the scene. It's the first project to, graduate from CNCF to like a stable release, and graduation or whatever they call it. They were just talking about it at KubeCon in EU, which, by the way, I was just presenting on Friday at KubeCon in Copenhagen, and then I was at Build in Seattle Saturday, Sunday, Monday, flew home Tuesday. So if I'm a little bit like spacey, that might be why, possibly. Time zones. What? The interesting thing about Kubernetes is, again, it's not new, but it's just started to become a lot more of a consensus. Like, okay, this works. This is what we're going to do. We'll go into a little bit more detail about that, but I wanted to mention it in the context of what's going on in the container ecosystem. Because again, it's like, oh, 2014, that was a while ago. But again, I wanted to give you a quick look at, and this is, I grabbed the list of logos from the CNCF project list, the Cloud Native Computing Foundation project list yesterday. So this is relatively up to date. I didn't differentiate them between the ones, well, the one, Kubernetes is the only graduated one, and then the other ones in the other phases of project acceptance. But the reason I wanted to put all these logos up here is because I wanted to make it clear, and the slides will be online later so you can kind of examine them in detail if you can't read them, but this is talking about things like distributed tracing and logging and service discovery and messaging, NATs, like service mesh stuff, security. These are a lot of things that are not just run your application in a container. Like it's a broad ecosystem. There's a lot of stuff going on in the container ecosystem that is not just having a container. I think that's the reason that's valuable to point out is because I think there's a large temptation to try to roll our own on just about any of this stuff. And it's probably worth looking and seeing if there's a project with maybe a few stars on GitHub, maybe a few contributors who aren't you. I read proposals for KubeCon EU, and I think I rated like 60 different service mesh related proposals. So I think we were definitely having like the Istio drinking game in Copenhagen. But just because a particular topic like service mesh is one that everybody's excited about, it doesn't mean that every single open source project that's out there is one that you want to necessarily YOLO out into production tomorrow. So like do your due diligence and see what the ecosystem and community looks like around any of these projects, these or any other projects, before you decide to make them part of your production stack. It's kind of the warning on that. I've used a number of these and they're good. I mean, the Prometheus people, for example, have done a really good job, but that doesn't mean that it's right for you. So like that's kind of the like TLDR on containers is we don't use containers just because we have a lot of, Sun nostalgia and really super miss zones. Like that's not why we're using containers, right? We're using them because they solve a problem for us, hopefully. If they introduce more incidental complexity than the problems they actually solve, they're probably not the right choice for whatever it is we're trying to do with them. And the complexity is non-zero. Like I think it is important to reiterate that because especially, I actually had, and I want to say it was like over a year ago, I had someone come up to me at a conference in kind of an open space, discussion forum setting and say, so our VP has decided that we should introduce containers and microservices in Q3. So what do you think of that? And I was like, what problem are you trying to solve? Like, are we trying to solve like your VP wants their level up and their promotion and their like checklist of accomplishments? Because these are all great things, but do them for the reason that they are solving a problem that you have, not just because they're a thing that exists in the world. Okay, so that brings us to Kubernetes. This, by the way, Easter egg for our Minnesotans. I don't say this when I'm in non-Minnesota places, but this is from the Tall Ship. I took this picture at the Tall Ship Festival up at Lake Superior in Duluth a couple years ago. So very exciting, especially because I was like looking for pictures for a talk a while ago and looking for something that looked kind of nautical for a Kubernetes talk. I was like, what? I was like, I have these pictures I took years ago. Okay, so I think the first important thing to think about with Kubernetes is that this is a complex system. And this is not one of the complex systems where you can say like, oh, it's okay, like I'll read the README and it'll be fine. There's a lot of complexity there. And as much as I like to say computers are easy, people are hard, like that's not actually true, right? Like people are hard, computers are also hard. And this is the kind of system that if you think you need, a scheduler of some sort, and you're not sure if Kubernetes is what you need, you owe it to yourself to look at things like Mesos, or Nomad from HashiCorp, and just see if because they are simpler systems, see if they solve the problems you have so that you don't need to borrow trouble by taking on a lot of incidental complexity that isn't buying you anything. Like people always say like, ask your doctor if Kubernetes is right for you. And it's like, I can't answer that question because I don't understand your use case, but you do. So that's kind of, just because the hype says Kubernetes is right for everyone does not mean it is. So that's the most important thing right there. I also kind of want to put a shout out to, my attack kitten, who is very, obviously is like a Docker expert and everything else, but also is very concerned about what happens the next day. Because you can stand up a very complex system in production, and then the next day and the next week, and there's more heartbleed or shell shock, or there's your management signed a contract with a different cloud provider, and you suddenly have to migrate a whole bunch of stuff that you ended up using some things that were tied to your cloud provider in ways that you didn't fully understand. Like there's a lot of places that your day 2 operations, and by day 2, I mean like every day after the first day where you launch it and everything is shiny and perfect and ideal. Like day 1 is really short, and day 2 is going to last until the heat death of the universe, because once somebody gets something working, they're probably not going to want you to turn it off or put a new thing in place next month. So that's it's worth considering the complexity before you move into something like Kubernetes. But if you do decide to move into it, these are a few diagrams, that the new stack put up that I thought were decent. But well, if you want to go into a lot more like hands-on use of Kubernetes, I'm running a workshop tomorrow. I don't know which room it's going to be in, workshop room, whatever that is, but it's like 3 hours in the morning. If you just want the high-level overview, though, there's probably the most important thing to start with is your Kubernetes is going to have different processes running on like your master or your control plane. Calling it a master node, besides the obvious terminology issues, there's not always just one node. First of all, you can have multiple nodes in your control plane, and you can also set these things called taints and tolerations to determine whether or not some processes are going to run only on the control plane or only on the worker nodes or other. So Kubernetes is in some ways very unopinionated. Like there's a lot of ways to configure it. You can do just about anything you can think of, which is great and also very complex and confusing. So you go to try to use it and you're like, excellent, there are 700 configuration options. I have no idea what to do next. So that's one of the things to worry about. But probably the main way you interact with the system is by talking to the API endpoint with like a command like kube control or kube cuddle or whatever you want to call it. There's holy wars about that. But you're mostly going to be using a CLI or perhaps a GUI to interact with the API. The API is talking to your control plane, and then any work is being fanned out to your worker nodes. The way the network is set up for these is it's a flat network, like everything can see everything else, which when you decide you want to go to Kubernetes and set that up inside your organization, the security team, the networking team might have a lot of opinions about the totally flat network where everything can talk to everything else. So like that's kind of the caveat of you probably want to have those discussions across your organization. People are hard with your security team and with your networking team. If you're in a large enough organization that you have all these different teams, if you're a software developer and you very much want this, but there's an IT operations team that runs all of that vSphere and sadness, like they may not be able to give you a network that's set up in such a way that Kubernetes will even work. So it's worth having those discussions early so that you don't have great disappointment later. Okay, so specific things running on the master. And again, like mostly this stuff can run in containers for high availability and reducing the complexity for like say etcd, that can run just like on the metal. There's a lot of different ways you can configure this. The default configurations that you would set up with like most of the tutorials and stuff out there, you're just going to have one etcd. That is your key value store that stores all your state. And let's see, you're going to have the scheduler is going to put processes out on the worker nodes. Then there's the thing about Kubernetes is, and a lot of us have spent a lot of time with like imperative systems, like imperative configuration management systems like Puppet or Chef or Ansible or whatever, are going to say, go configure this in this way. And they're going to try to do that. Kubernetes is a declarative system. So instead, think of it as like a desired state system. You state what you expect. Like I expect this many workers, and I expect all of the workers to be running, this many of these daemon sets or whatever. And then I expect this many pods for this application. And then if a pod fails, Kubernetes just spins up another one. So instead of you having to like have something that runs to spin it up, you just say, this is how many we should have. Now maintain this. Okay, and then on the nodes themselves, there's a bit, again, back to there are a lot of different ways to do this. You don't actually have to use Docker, for example. There's the like the cryo stuff. There's basically open source projects that are coming along that are maturing quickly that let you replace Docker with something like Rocket or cryo or whatever. Docker is more, I think most people, not everyone, but most people I know who work at Docker don't even work there anymore, but it's been like a pretty long-standing, well-established project in this space. So I'm not saying don't use Docker. I'm saying that you do have choices, but like the default that a lot of installations are going to have is Docker, and that's fine. But that is one of the many swappable parts. Another one to consider is the overlay network. So, and it's sort of in this picture, up with the optional add-ons. Like in our workshop, for example, we use Weave, but you don't have to. I think there's like 15 or 16 supported options for the overlay network. You don't need to use that specific one. It's just what we use. Like this example shows FluentD for the logging, but you don't have to use FluentD. You can plug in anything else that you want for logging. You are probably not going to, well, I shouldn't say that because there are projects to use a different kube proxy if, for example, you want to use a network with different characteristics. The kubelet is another interesting one because that's going to run on every node. And there is a kind of cool project that I'll show you some stuff about in a bit called Virtual Kubelet that lets you add a node that isn't really a node to your Kubernetes cluster so that you can add, say, your whole other data center as a node in your Kubernetes cluster. And your Kubernetes cluster will see it as a node, but it can behave with the characteristics of, like a cluster at your data center. Okay, let's see. Oh, and the containers, and you can have multiple containers running inside a pod, and they all share the IP address of the pod. So that's, I think the pod structure is probably the part that's the most like a little bewildering if you're not used to dealing with Kubernetes, because you can have multiple things running inside the same pod. You don't always want to, but you can. It's like pod affinity and anti-affinity stuff. There's a lot of things that are configurable. I know I keep saying that, but like that's why Kubernetes has a kind of steep learning curve, because there's a lot of pieces that are configurable. But this is, in general, what the architecture looks like. Oh, and you have to have an image registry. In our workshop tomorrow, we're going to just use a self-hosted registry right on the nodes in Azure that you're using. But all of the public clouds and probably like your employer might have their own image registry that's like private. That, keep in mind though, that with Kubernetes, just like if you're using Docker, you're not going to want to put like sensitive information in your images that then get pushed to your image registry, because you never know what's going to happen. There's a lot of attacks out there that make it possible to leak information. So it's worth making sure that you're using decent secrets management. Your public cloud providers have different options. HashiCorp has Vault. Like there's different secrets management that you should probably consider using. Like don't just put the secrets in your images, because that way it leads to sadness and people running Bitcoin miners on your infrastructure, which you don't want. Okay, so by the way, like if you come to the workshop tomorrow or do any other like thing at a conference where you do a lot of hands-on things with Kubernetes and you learn a ton and it's really exciting, and your coworkers have FOMO and wish that they were here, and then you go back to the office and they say, teach us everything that you learned. And you're like, because it's actually really hard, right? Like it's hard to condense down, distill down for everyone everything that you learned at the conference. And I would say we consider Kubernetes to be something that democratizes distributed systems for us. Like it makes it a lot more accessible to run a distributed system that you don't have to do a lot of bespoke artisanal like wiring together of scripts to make it happen. So the answer for like democratizing understanding of Kubernetes is open source Kubernetes training, of course. So this is what we're going to work through in the workshop tomorrow, but it's all free. It's all open source. You can work on it yourself. There are instructions in the repo for setting up instances in AWS and in Azure and locally. And pull requests accepted if anybody uses Google Compute or Google Cloud and wants to send pull requests for setting that up. That would be great. Yeah, this is created by Jerome Pedizzoni. He was one of the early employees at .cloud, which became Docker. So he knows a few things about containers. Okay, so by the way, when I say like Kubernetes 101, I feel like that also can cover a huge amount of territory. Like if you look at Kelsey Hightower's Kubernetes the Hard Way, you could spend that like a 2-day workshop. You could spend the first half of the first day just setting up your Kubernetes nodes. So like I like to think of it as start with things that might be familiar to people, just like the command line or Docker, and limit the unnecessary optionality that can make it really difficult to get started using stuff. So like we do some, with our setup, we do some opinionated stuff with Weave and with kubeadm, because it can be very distracting to choose off of the 700 choice, 700 item menu before you even know what you want. Like sometimes constraints can be freeing. And then also just the idea of building your understanding slowly over time, because also I've been, and you've probably been in that situation where you get a giant info dump and you're like, I can't even distinguish which of these things are important or figure out how they work together. And that's an easy place to be with Kubernetes. It's definitely where I started with it. So, okay. So yeah, in general, like the way that we like to teach people this stuff is make it as hands-on as possible. Like if you're pulling on all those ropes yourself. If you're breaking and fixing an application, it's a lot easier than just knowing a bunch or just seeing a bunch of theory. So that's kind of, we'll see. I've given this workshop like 6 times now, and people appreciate getting the hands-on. So there's that. Also, just one thought exercise about the kind of application you would want to put on a distributed platform like Kubernetes is you want something that you need the ability to independently scale up and down different parts of it, right? Because if all you have is, WebSphere and sadness, like you don't need that. So it's worth considering, especially if you have a giant monolithic application. It's worth considering. Take a look at, Sam Newman's microservices book, and Sam Newman wrote a really good microservices book for O'Reilly a couple years ago. But like, think about decomposing your monolith, because otherwise, if you just have one giant thing, it doesn't even make sense for you to put it on a distributed cluster. It's also worth considering, though, as this game like makes clear, that if you go to distributed systems, spoiler alert, your problems don't actually go away. Like, you might actually get more different exciting problems. And that has to do with what a former boss of mine at Drama Fever, actually, Tim Gross, likes to call conservation of complexity. Like, your application and your system are going to have a certain amount of complexity. And if you move some of that complexity by, say, moving your IPC to network calls, you still have it. It's just different, but it's not gone. And that's, I think, one of the traps that people fall into when they start moving to systems, like Kubernetes, is they think that will make things easier, and it will make some things easier. It'll make other things, like, say, figuring out why something is slow, a lot harder. And that's why I pointed out a couple of those projects on the CNCF slide. It's worth considering how you're going to solve the microservices murder mystery problem. Like, think about that before you even decompose your system into that kind of setup, because you're going to need something like distributed tracing. You're going to need some kind of observability tooling, or you will have bought yourself a world of hurt that's like much more terrifying than it was before. And then people will be angry at you and wonder why you went to this terrible new system. And you're like, the system isn't terrible. We're just using it wrong. And no one likes that explanation. So, okay. In terms of both in our sample apps that we'll do in the workshop tomorrow, but also in the way you set up your systems, it's worth considering. And I know there are going to be some good talks later on the human factors stuff and documentation and whatnot. And it's worth considering, if you're the one setting up the clusters and the systems, and, like, say, the end-to-end pipelines that put code into production, it's worth considering, do all of the people who are going to use that need a complete and thorough understanding of it? Not necessarily, but they probably need to know exactly what the failure states that their app can get into will look like. And that's the sort of thing that, like, it's a lot easier if you think about ahead of time, as opposed to trying to paste some observability on later ends up being really tricky. So thinking about, like, things like Istio, things like any kind of sidecars that you want to use that make it easier for anything that makes it easier for people to add tracing without necessarily having to make a lot of modifications to their app is going to be, like, a big win. And I think that it's easy to, and I don't know about you, but I see this in a lot of conference talks, especially. You have, like, the hello world and the magic and the hand waving, and you're like, it can't possibly be that simple. And it definitely is not that simple. Like, there's a lot of complexity in these systems. That's why they're called complex systems. And as you start looking under the surface, there's more and more and more complexity. And I think that's where it's really valuable to, if there's a fast-moving project that you're paying a lot of attention to, like, look at the materials coming out of their SIG, like their working group, because there can be breaking changes in point releases. I'm sorry, but there are. There was in Kubernetes 1.10.0, there was a breaking change that made it impossible to tell just from the CLI output if something was the deployment or the pod, and like all of the like letters ahead of your application name that would tell you what it was all went away. And they fixed it in 1.10.1, but that's the sort of thing that happens in these really fast-moving projects. And so I would say, like, unlike your typical enterprise software where we can pretty much just like talk to the vendor, okay, there are hosted and managed Kubernetes systems. You know, the Azure Kubernetes service is going to be going GA shortly. Heptio, for example, does a really good, that's a startup founded by Craig McLuckie and Joe Beta, who are two of the three people who developed Kubernetes at Google, are doing a startup called Heptio. The third one, Brendan Burns, actually works at Microsoft now. But they have a managed Kubernetes for any cloud solutions. Like, there are people out there who will hold your hand through this, but the reality is that even if you have good vendor support, this is going to be the kind of project that you're going to need to pay a little bit more attention to the issues on GitHub than you would for a more mature project. That's the as warning and caveat-y as I can be, because there's a lot of messiness if you choose to use this. And I kind of feel like at this point, maybe it's sounding to some of you like Kubernetes sounds like it's not fully baked. Maybe I shouldn't use it. Like, maybe you shouldn't. Again, like, you should probably use it if it solves problems that you have. And you'll know because you'll have a situation where you're launching containers on your VMs, but the containers don't have their lifecycle managed, and sometimes they die. And your VMs seem massively underutilized, but then if you try to like bin pack the containers onto them, you end up with, you know, things that probably shouldn't be running on the same node, running on the same node. Like, if you find yourself writing a lot of bespoke artisanal janky bash in order to solve those problems, then yes, I mean, Kubernetes might be right for you. But it reminds me, honestly, of this sign that I saw when my spouse and I went hiking in Iceland for our 20th anniversary. And we went hiking on a glacier. And we go, and I can't read Icelandic, so I'm not sure if the top part says the same thing, but underneath in English, it said, "Attention, natural hazard, calving an unstable glacier, do not pass this point." And our guide was like, "All right, then, hiking along with our ice picks." And like, should we be doing this? And I feel like there's a lot of places in our code bases where we have some things that we're like, should we be doing this? And I would say it's not that you, and he was like, "Oh no, it's fine." Like, okay, that explanation, "Oh no, it's fine," it's not that comforting, but sure. I think it's worth, when you're introducing these kind of systems into your organization, it's worth writing down the constraints and the decisions and the places that it's fine and the places that it's not fine, and write down the things you're terrified of. Because I assure you, if you would like to go to the Boundary Waters this summer, like, you want to write down those things that are terrifying so that somebody else can solve those problems without you being there. Otherwise, you'll never be allowed to leave cell coverage, and that's just depressing, right? I mean, we want to be able to leave cell coverage, I mean. Okay, so you've decided to get you some Kubernetes, and that's cool. But once you've decided to have some Kubernetes, there's a bunch of other things to start thinking about. Like, there are tools that you can use to make your interaction with Kubernetes easier. I don't particularly endorse these. I'm just saying these are a couple of open source projects that you can go look at that can help. There are also hosted solutions. And again, I work for one of these cloud providers. You can probably guess by the t-shirt which. But it's not necessarily important that you give money to my specific employer. The important thing is that if you don't need to be interacting with the control plane, if you just need to run some clusters and interact with your code and your nodes, it's worth looking at the hosted options, specifically because managing the control plane of Kubernetes is an entirely different beast than just using Kubernetes. And so if you don't need the customizability and configurability that would come with managing your own control plane, it might make sense for you to not. And again, this is not a question that I can answer for you, but it's probably worth exploring, especially in your initial phases of adoption. It's worth exploring one of the managed control plane options, just because that way you have significantly less, I'm not going to say no, because that would be a lie, but you have significantly less complexity to think about when you're trying one of these options. Okay, so there's a few projects in this space that, again, are open source projects that I think I want to highlight because they're interesting and give you some stuff to look at. Helm is like the missing package manager for Kubernetes. So when you start managing applications on Kubernetes and you have a whole bunch of YAML, I feel like there has to be a content warning for YAML. I'm sorry if YAML triggers you, but there is so much YAML. And managing all of the YAML files starts to be messy, kind of horrible, and Helm can help with that. So it's worth looking at just because of all the messiness. And Brigade is another option. If you would prefer to write some JavaScript and you're really sick of YAML, it's worth looking at writing some configuration in a language that you're more comfortable with, and then you can also put some actual actions in the configuration files themselves. So that's possibly worth looking at. And then I mentioned virtual kubelet earlier, and that's kind of some members of my team and a few other people from various places in the open source ecosystem spiked that project right before KubeCon in Austin last December, and it's really been taking off. And it was kind of exciting in Copenhagen last week because we had AWS people working with Microsoft people across clouds working on virtual kubelet, because the idea is, and I have a little bit more detail on how this project works, like if you can't read what it says there, it says like typical kubelets, they put the pod and container operations, for each node together. Virtual kubelet, it registers itself as a node. So it acts as if it's a node in your cluster, but it can be something completely different. It can be like your other data center, it's pretty powerful. You can have things that wouldn't just be a node act as if they were a node in terms of taking workloads or joining or leaving clusters. So it expands the concept of what can be in your Kubernetes cluster. So kind of cool. Okay, so and then I was kind of hating on YOLO before, and I spent 15 years on call for production, so I have a deep skepticism of things that people YOLO out to production that page me at 2 in the morning. Like that tends to just make me angry. But I think this is an exciting space. This is an exciting, fast-moving space. And it's also a space where there's exciting open source projects like the Virtual Kubelet project and Helm and Brigade, like all these projects that you could be contributing to if you wanted to. So it's probably worth going down the rabbit hole of what's interesting to you and trying it. And if it turns out that it does not meet your, production grade needs for your organization, that's probably fine. I wouldn't advocate resume-driven development. You can probably do a little bit of digging and diving and exploring in the Kubernetes space and have it be totally relevant to your employer's interest. That said, there's another speaker who I think is actually speaking in the next time slot, though I think different room, but the next time slot after this, who you should definitely go check out. I'm going to be in that talk, live tweeting after this. And that's Laura Bell, is founder of SafeStack from New Zealand, all the way from New Zealand to come talk to us here in Minnesota. And when I was talking before about Settlers of Catan and about disruption and whatnot, and I think about Simon Wardley's Pioneers, Settlers, Town Planners model. If you're not familiar with it, the idea just is you get some people who do the first proof of concept, and then you get some people who scale it up, and then you get some people who make it completely turnkey. And those are, if you've worked at startups, you probably recognize those roles, because those are kind of, sometimes your startup gets to the point where your original founder kind of needs to take a step back because they aren't really in a place where they want to scale it all the way up. And I will admit that I'm Team Settler. Come on, #OpsLife. I'm obviously Team Settler. I'm really not the, instantiate the totally new thing person. It's kind of I came in to run the DevOps Days organization after it had already been running for 5 years. And I scaled it way up, but it is in the land of software development. I think that we often glorify the innovation, and we glorify the you had your original idea and now you've shipped it. You shipped, yay! Let's celebrate. We're done, right? Because we shipped. It's like, okay, so you shipped. That's cool, but you probably want to also provide actual value, and you probably want to also be able to patch. And it would be nice if you could upgrade, and it would be great if you could meet new end user requirements that come along. And so I like that mentality of it's cool to build things, but it's also really great to build things that are maintainable so that it doesn't have to be boring or depressing to maintain them. And I think that's one of the things that excites me the most about things like cloud and containers and Kubernetes is it makes systems that abstract away some of the toil, as the Google SRE book likes to call it, abstract away some of the unnecessary, repetitive, heavy lifting that we've all done with. We all have a bunch of scripts in our back pocket that can do that stuff, but it's kind of nice not to have to. And so I think that's the thing that's most exciting for me about Kubernetes, because you can be settlers with good tools, which is kind of great. And I also, looking at my coworker, Eric St. Martin, is one of the people who runs GopherCon and the Go Time FM podcast. And of course you're thinking like, yeah, I mean, in the Go space, there's all this exciting stuff. It's like, yeah, there is, but it's also still not entirely new. And it also, he's pointed out, and I think he's right, that much like the halt and catch fire quote, like Kubernetes is not our end game. Like, we're not like, and now, Kubernetes, we have Kubernetes now, computing is done. Like, that's ridiculous, right? But it is a really cool tool that helps us get to the next stage of whatever it is we're trying to build. Like, the kinds of distributed systems that we can build on a system like Kubernetes are really cool. And I'm excited about those. So yeah, that's kind of my summary of like the Kubernetes section here is basically people get really excited about orchestration. And they should, because orchestrating applications on distributed systems is hard and terrible. And so, yes, like they should be excited about it, but orchestration isn't the only win, and it isn't the only component. It isn't the only thing that we're doing. And we're plugging this into a wider ecosystem that has considerations like security. It has considerations like, oh, we have this giant data center that's not going away. Wouldn't it be nice if we could harness those resources and plug them into our Kubernetes cluster in the cloud? Things like that. And I think having a lot of that stuff out there is a good thing to know about when you're starting to use this. Just that, especially because that helps you say, banish the objections from the naysayers that don't want to let you play with the shiny toys. All right, so I did say I don't have any hot dish pictures, but I do have a Minnesota picture here at least. And if anybody recognize this, anybody know where this is? Yeah, I see some smiles. Like, this is over by the University of Minnesota campus. I was cycling a couple years ago with my spouse to our community garden spot, as one does. And I was like, stop, I have to take a picture. He's like, what are you taking a picture of? I said, all of the IT cliches. They're all here. It's perfect. I didn't have to Photoshop it at all. I mean, it's got, clouds, which you may or may not be able to log into them, but I assure you, the servers are still there. And silos that hopefully your organization is not in, but they do exist. And I do have some sad news for you. If somebody decided that you could buy 20 units of DevOps in that shipping container, like, not actually true. Like, you can't buy good cross-team collaboration. Like, that's the thing you have to do. What you can do for your team is come to our conference if you are into that sort of thing, because this is, if you're trying to build these sort of systems, take a look at devopsdays.org. Click on, there are, like I mentioned, there are a lot of cities, but click on Minneapolis. It's coming up in the next couple of months here. And we have a number of talks about things like Kubernetes. I think we have at least 2 Kubernetes talks, one about a production use case and one about security, which is a thing that people like. Who knew? So the reason I put a slide in, I just put the slide in last night because I was like, oh, I should tell people our best price is ending May 31st. So if you would like to come in July, get your ticket now. And I just want to close with, I tweeted this and it got some entertained reactions. And I think the part that I gotta say, it's 2018. I'm pretty sure we live in the darkest timeline, but there are some things about this timeline that are kind of cool. And the part where I have a Mac with a Microsoft asset tag on it, and my job is all about Linux and like the cloud and containers, and my paycheck, which is virtual because they don't have paper checks anymore, says Microsoft on it, is pretty cool. And I also think that there are places where you get people having I know I had the like stereotype of, oh, I know what this organization's about, or oh, I know what this tech stack is about, or oh, I know what this person is about. And I think it's worth like reassessing our assumptions sometimes, because I gotta say, like, yeah, okay, I used jails and I used zones, but that doesn't mean that I knew everything about containers. And when I started using Docker, I was like, oh, hey, I am learning new stuff. And I think it's, as you go about like the rest of the conference, just doing that reset on some of your expectations and your assumptions is kind of a good place to go, I think. So yeah, I have a little bit of further reading for you here. You can take a look at DevOps Days. You can take a look at the open source container training that I'm going to be running tomorrow. So if you want to go to a different workshop that is first thing tomorrow, don't come to mine and do the workshop online because it's free and open source. On the other hand, you get instances and guidance tomorrow, so you have choices. And it's worth checking out the docs for AKS if you're considering what managed Kubernetes service might be right for you. I think the docs are really good. So if you're not an Azure customer, that's fine. Like I am not in sales and I do not carry a quota, so I don't care what you buy. But if you take a look at those docs, it'll help you understand the trade-offs in a managed system for Kubernetes that would probably be valuable to you, whichever cloud you're using. And yeah, I put a link up here too to the virtual kubelet project, just because I think it's really cool. This is kind of one of those like building out the distributed systems to make them even better. And that's it. That's what I've got. I've got a little bit of time for questions if people want to have questions, or I've seated you back a couple of minutes to actually, enjoy your break. I guess the main thing that I want you to take away from this is there's a lot of cool things in this ecosystem. There's a lot to be excited about. And there's also a lot of complexity. So don't let somebody throw all the complexity at you and make it hard for you. And also don't let somebody convince you that you have to use something just because it exists in the world. Like you don't. You can actually just use the things that are right for you. All right. Thank you very much. I do have a question, yes. Mm-hmm. Yeah. Yeah. So the question is, how do you communicate to your developers the new constraints in an exciting new containerized world? Does that summarize it? Okay. So I think it's pretty important, and no one wants to hear this because it's depressing, but you know how all of those legacy systems that exist where your state lives, and that's also where the customers and the money are, and those are the ones that won't let you change, so you still have to have the new stuff talk to the old state? Like that's probably not going away, right? Like you probably don't get to move your entire data warehouse instantly. So you have your new application and it's all containerized or whatever, but the way the application worked before, it might have been that they just like had a persistent, connection and could just write to the database, or just even horrors, write to like local disk. And it's important for developers to understand that their containers that their application is running in now could be ephemeral. So like you shouldn't assume that after you write something, if you go to read it, you're getting the same it. So like this is the having them understand the constraints around the way their data is stored is probably the most important and dangerous thing. That with a more complex distributed system, especially one that has some possibly ephemeral pieces, it's like really important for them to understand that. there's a lot of dissys 101 like that we probably, it's a little bit out of scope to go into in a like quick overview like this, but I would say another really good thing for them to think about is how many of their thing could be running at once, because with the kind of scaling that would happen in a Kubernetes-based clusterized system, there could be multiple nodes behind a load balancer that are answering. And if the way they developed their application before, it was just running on the one server, and this isn't a Kubernetes specific problem, but it is a problem that happens when you move to a larger distributed system that you didn't have before, is like, okay, what are you relying on that, especially in terms of like, like dirty writes, or what are you relying on in terms of reading back something that you wrote, or cap theorem is real, and I didn't go into cap theorem here, but the theory is that you can choose two of consistency, availability, and partition tolerance. But as a distributed systems expert, Katie McCaffrey likes to put it, you don't get to choose not to have partitions because physics and math. So really, you just get to choose, what do you want first, consistency or availability? Which is to say, if you write something and then you go to read it and it's not there, like, are you going to wait? How long are you going to wait? Do you wait until the heat death of the universe? You probably have constraints. And for your application, you have to decide what those are. And then for your developers, you have to tell them what kind of choices you've made in the trade-offs between consistency and availability for your data stores. Like, for example, say you're showing say user likes or something for an object on your website. It might not be important if the likes are 100% current. However, if this user just likes something, it's very important that whatever action they just took is shown back to them. Because otherwise, they're like, it didn't work. So I don't know if that answers your question, but. Yeah. And to repeat what he's saying, like, we do need two-way communication, right? You can't have an ops team that acts like the high priesthood from on high and says, this is the way things are now, and your developers are like, okay, that's not going to work. I mean, you have to hear from the people developing your applications, oh, only one of this can be running at once, or everything is going to be bad. This is going to need to be able to get answers from this, and the round trip needs to complete, or these are going to be inconsistent. And then we might show people a wrong amount in their bank balance that's left. I mean, there are things where it's much more important to show the right thing. Like, say, in your bank balance, you would probably not be okay with that just kind of varying randomly. So you do need, and this is back to that, like, humans are sometimes harder than computers, because you need that communication inside the organization that will allow those feedback loops to happen. And so, like, if you're in an organization where, security dictates something and then everyone else just kind of works around it but doesn't talk about it, that's not going to work super well. And it'll work way less well when you have complex distributed systems like this. So if you do have application development teams that have things that they can't change yet, like, that has to be told to the people running the distributed system platform that the application is going to be on, ideally before the application migrates to that platform. Because a lot of these things, like the auto-scaling stuff, you can set in Kubernetes. We talked a little bit about the things you can set on your control plane and on your nodes. And you can set for a specific app, and we'll do this if you do the workshop with me tomorrow, we'll do this. You can set, we want one and only one of these per node. Like, you can set that. Like, that's a setting that you can set on a per application basis for an application running in your Kubernetes cluster. Like, there are things like that that can be configured. But yeah, absolutely, you're right. They have to, the people who know those things need to communicate them to the people who can set those things. Which, of course, makes the argument for self-service as much as possible, which, fortunately, since Kubernetes democratizes a lot of these distributed systems, it's possible to set it so that your application owner just writes some YAML, I know, but they write some YAML that says this is how this application needs to be constrained and can behave. Yeah. Yes. it's actually pretty trivial because you have all your configuration in your YAML. You're just not putting configuration for control plane because you don't need that yet. But Kubernetes is all of the, I can't speak to every managed Kubernetes that exists in the world. I can say the 3 major clouds all have a consistent, like you can use the exact same YAML with a self-managed or with a hosted. So I would say this is one of those, the Cloud Native Computing Foundation kind of puts various and sundry seals of approval on things. And I would say if you're going to use some sort of mystery cloud with possible dubious choices, look and see what the CNCF has to say about them before you decide to move into somebody's hosted solution. But at least the major providers, it's fine. Yeah. All right. All right, if we don't have any more questions, I think I'm going to thank you all for your time and hope to see you at the workshop tomorrow. All right, thanks.